Hello, good morning to all of you. Today we are going to see next point that are the review of natural resources. Myself Mukul Barwanta, Assistant Professor, Department of Botany, Sanjeevani Arts Commerce Science College, Kopargaon. Let's start what is meant by natural resources. Previously and many more time I have discussed about the natural resources. The resources that provide by the nature to us, that is known as a natural resources. Let's say introductory part. First review with the fossil fuels that given by the nature, that may be a biotic resources or the abiotic resources. First we are going to see abiotic resources, that may be a fossil fuels. The fossil fuels generic terms for the non-renewable carbon based energy source. Each solid fuels, natural gas and oil, have their origin in a plants and animal that lived millions of years ago on the earth, underwent transformation through a chemical and the physical process. Fossil fuel include coal, oil and the natural gas are currently the world primary energy source formed from the organic material. Over the course of the millions of years, fossil fuels have fuels US and global economic development are the part of in the past of century. Yet fossil fuels are the finite resources and they can be irreplaceable and the harm to the environment. Okay, that are the regarding to the fossil fuels. In that that means how they are formed and where they are in formation and why they are harming to environment. We all know that may be a fossil fuel, petrol, diesel, oil, or the any type of fuels that make up from the extraction from the rock, oceans, that can be. These gases insulate the planet and could lead to be a potential catastrophic changes in the earth climate. Technologies such as carbon capture and storage, that is a CCS, it helps to reduce the greenhouse gas emission generated by fossil fuels. Nuclear energy can be a zero carbon alternative for the electricity generation, but other more is a sustainable solution exist energy efficiency and the renewable energy. The forms of fossil fuel, there are different forms, we will see the one by one. First it is a oil. Let's see oil. Oil is the world primary fuel source for the transportation. Most of oil is a pump out underground the reservoirs, but it can also found embedded in the shales, tar, sand. Once it is extracted, crude oil is processed and the oil refinery is creates. Fuel oil, gasoline, liquefied petroleum gas and the other non-fuel products such as pesticide, pharmaceutical and the plastics. Oil consists mainly of liquid hydrocarbon as well as the organic sulfur compounds, naphthalic acid, phenols amongst the other substances. It serves the as a fuel almost all mean the transport and important for the chemical industries. Beside the environmental degradation caused by oil spills, extraction, combustion, oil release from the fine particulates which can lead to the serious respiratory problems and is a major sources of a greenhouse gas and emission. Then coal. Coal is a form in a swampy ecosystem where the plant remains were safe by water and the mud. From the oxidation biodegradation, it is a sedimentary rock, but it is a harder forms such as anthracite coals. It can be regarded as a metamorphic rock because of later exposure, elevated temperature and pressure. It is a compound primarily carbon along the assorted with the other elements including the sulfur. Coal provide around 28% of our energy with oil provide 40%. Mind of you your figure have a changes in the page written, so check figures if you want to the quote them. That means the amount and the production we have to match them. The burning of a coal fuel, sulfur dioxide, acidic gas that contribute the formation of a acid rain. This can be largely avoided using the flue gas desulfurization to clean up gases before they are released into the atmosphere. This method uses the limestone and produces the gypsum for the building industry byproduct. However, it is uses in a lot of limestones. Then natural gases. Natural gas contain mainly methane can be distinguished by the composition of a further component where the burn source of heat or for the electricity generation, and it produces the lower carbon emission relatively other fossil fuels. Also it can be used as a energy storage systems integrating intermediate production of energy from the renewable sources from the wind and the solar plants. Natural gas also used to produce fertilizer, paints and the plastic. Natural gas is the most of the common transport by pipelines which make Canada key exporter, the United States, while the Russia remains the main supplier of much of Europe's. Increasingly, however, the natural gas is being transported by a ship in a liquefied forms, that is a LNG, to meet a greater global demand for the fuels. Natural gas burns the cleaner than the coal and the oil with almost zero sulfur dioxide emission and far fewer the nitrogen oxide particulate. The emission natural gas releases almost 30% less than the carbon dioxide than the oil, 43% less than the coal. However, the natural gas is still responsible for the 27% of a greenhouse gas emission in the United States. Then how the formation of a coal will be take place? Let's see. Millions of years ago, plants are the thrive in a large shallow swamp. They were the buried under the earth, owing to some natural phenomena, and the fossilized in a course of the time. A combination of the heat, pressure, bacterial action gradually converted into these buried remains into the coal. Plants contain the carbon compound, so coal is a mainly carbon. However, the different types of coal contain the different amounts of carbon. Peat, the first stage of formation of coal, has the lowest carbon content and the most inferior type of coal. It is the most from the action of anaerobic bacteria on a plant remains buried under the swamp. As shown in a figure, we can write below the surface up to depth to 1000 meter or so. The formation of a natural gas and the petroleum. Let's see petroleum. It is also called as a crude oil. Is found in a deep under the earth between the layer of a rock. So the name is a petroleum. Petroleum, that is petra means a rock, and the oleum, that means oils. Natural gas often found in association with the petroleum consist of the mostly methane, that is a CH4s. Both form from the remains the marine organisms that died and the collected floors of the seas of millions of the years ago. They remains the were decomposed the bacterial action and were buried under the layer of a sediment and deep of these under the earth with a high pressure temperature. Liquefied part product decomposition changes other into the gases. The liquid called as a petroleum and the sipped through a porous rock till the meet the non-porous rock. The collected over a water which had sipped out through the porous rock, and the gaseous product is called as natural gas and collected over the petroleum. Then utilization of fossil fuels. How they are utilizing? More than 75% world energy requirement are made by the fossil fuels. When we speak the energy requirement, we mean a commercial energy or the energy that brought or the sold, and not a energy from the crop residue, cattle dung, etc. that are the used by the poor of fossil fuels. Petrol meets the over 30% of the worldwide requirement of energy. In the Indian context, however, the coal is the most important fossil fuels, fulfilling the over the 65% of our energy need. Together, the fossil fuels needs over the meter 90% of India commercial energy, 59a and the b show the how energy used in the world and the India. In the figure we can see in the book, a large amount of the energy used the world, about the 30%, and goes into the producing the electricity. This has not been shown separately. In India, 75% of a total amount of coal used every year goes to produce electricity in thermal power station. Then problems over utilizing. We know that when any resources are there, that may be a renewable or the non-renewables, we use in a more quantity, that will be a shortage for the future generation. So the world is the present reserve fossil fuels took a millions of a year, and the present utilization of fuel is a much faster rate at which natural processes form them. It is said one day of consume the nature took the thousands of years to form naturally. Then if we do not bring down the rate which fossil fuels, we will the soon that run out them. That means simple things. We are the production rate is very low and the utilization rate is a very more, or the using rate is a very more. One day we have to face the problem of a shortage. For the preparation of fossil fuels, the natural process it is a very slow rate and the using rate it is a very fast. So we are the 101% there are the guarantee to facing the problem of a shortage. So we need to the use very slow rate by the fossil fuels. There are the no hard and the fast estimate how long fossil fuel will the last. At the current rate use the coal will probably last another 200 year, natural gas 200 to 30 years, and the rate of a consumption definitely increasing the growth population and the industry. As for the petroleum, no one the quit sure the about the how much petroleum there in the world. Still the specialists predict the shortage within the 15 years. Okay, that is in this rate we are using the more amount more than the 50 years. Only 50 years needs to be the fuels are in the our era, so that we need to the use very small quantity or the very urgency. Another problem of over dependence of fossil fuels, that the country of the world do not have equal reserves fuels resources. India is the example of a rich coal resource, being in the 14th is the largest producer of the world, but does not have a sufficient petroleum reserves. Okay, that are the best example. That are the crude oil or the coal. It is a very large 14th in the world. There are the 14th rank of India, but petroleum it is a very low. It has a import one third of a petroleum need for the developing country like ours. This is a great burden on us. Let's see review of natural resources by special reference with the radioactive minerals. We all know not only fossil fuels are the important resources. We should be think about the some electric or the radioactivity energy. Let's see radioactivities in the minerals that cause the inclusion of a natural occurring radioactive elements. Minerals composition, the degree of a radioactivity dependent on the concentration and the isotope present the minerals. For the most part of a minerals contain the potassium, uranium, thorium are radioactive. The list of the tables are explained, but we are considering mineral activity due to the alpha and beta gamma radiation from the unstable isotopes. Composition, alpha decay due to ejection of a helium nucleus, 2 proton and 2 neutron from the parent isotope. This alpha particle accompanies gamma radiation, and the daughter isotopes which 2 proton and 2 proton lighter than the parent isotope. Beta decay due to the ejection of electron from neutron in the parent nucleus. These particles accompanied by the gamma radiation, and the daughter isotopes which are the 1 proton heavier and 1 proton which is lighter than the parent isotopes. The electron capture, that is EC decay, very rare and a result of nucleus capturing one of the atoms of orbital of electron. This decay accompanied by gamma radiation and daughter isotopes, which one of the neutron heavier and the proton is lighter than the parent isotopes. Let's see radiation dose calculation. What is my radiation dose? The rad or the radiation absorbance dose is the unit of absorb equivalent to the deposition of 100 AX energy per gram of a tissue. A REM that is a Röntgen equivalent to the man is a unit of a absorbed dose taken into the accounts of a relative biological damage caused by a various ways that ionizing the radiation deposit its energy tissue. Then Röntgen it is a measure the gamma and the beta radiation dose based on the amount of ionization the year. Then what should be precaution will be taken during the radioactivity? What is the precaution can be done? Handle the specimen with a little possible. The good strategy place of a specimen. Transparent container which are the seal. Wash your hand handling the specimen. Do not smoke or the eat or the sleep near the specimen. Limit the specimen size since the exposure related to amount of mineral present. Secure the specimen from the children of a curious adult. Alpha and the beta radiation are absorbed by a cup or the feet, by a ear or the glass cabinet windows. Gamma radiation is not. The main environmental exposure of a hazard from the radioactive minerals comes from the buildup radon gas emitted by a uranium and the thorium being a minerals. Museum who display the large radioactive specimen provide vent to the outside. Good strategy for the personal collectors to the place of a cheap aquarium, pump inside and the closed mineral cabinet, route the output pump of the outside. Then disposal of a natural occurring radioactive minerals. How can we dispose the radioactive minerals? The number of disposal of option are the exist that may be appropriate from a norm waste depending the waste classification level including near the surface buried disposal municipal tips or the landfills disposal into the underground mines or the cemented backfilling injection into the old oil field slated abdomen plugging with some form of encapsulation disposal into the mine mine waste rock into dump smelter slag dump mine tailing dam or the power plant ash ponds that we have to do. Then the regulation of a naturally occurring the radioactive material. How will be regulated? Regulation approach the norm issue with the Australia guided to the Australian Radiation Protection Nuclear Safety Agency. The Commonwealth and each state and the territory government has regulatory systems for the radiation protection include with the use of radioactive minerals in each jurisdictions. The regulation includes exemption limit on an example of the total activity concentration of radioactive materials to be regulated. Waste rock processes, tailing and the product containing elevated concentration naturally occurring radionuclides are covered by the ARPSNA code practice and the safely guided radiation protection. The radioactive waste management mining mineral processing 2005. The code practice near the surface of disposal of radioactive waste in Australia NHR MC 1992 currently under the revision. Is applicable the bulk norms residue disposal. Those are the seeking information on a norms can be consult ARPSNA safety guides managements of naturally occurring the radioactive materials. That is a regulation of radioactive radioactive materials. That means which are the act or the which are the norms are given to disposal or the how we can go through the using that. Okay, this is about today's lecture, that is a review of natural resources. That means how there are the content are present, review only the do the review. Okay, if you have any doubts, please comment below the section. Thank you.